Hi class, this is Neil, and this is lesson 1 of Unit 10. In this lesson, we're looking at probability, sample space, and mutually exclusive events. So first, probability. Probability, I'm sure, is something that you have encountered before, either in everyday life situations such as the weather or making a bet on something. What probability describes is really the likelihood of an event occurring. It's normally expressed as a decimal, a percent, or a fraction. And really, the mathematical definition is that probability, I'm going to write that definition here, that probability is the same as the number of ways an event can happen divided by the total number of outcomes of an event. So kind of the classic definition of probability is really flipping a coin. So there are really two possible outcomes there. You either land on a head or on a tail. And the total number of outcomes is 2. Now, the notation that we use to describe probability of an event occurring, and so I'll write that here. So the probability of event A occurring. So the way we describe that with mathematical notation is really P of A. Now, the sample space is often used when we're describing all the possible events that are possible. So the definition of sample space is simply all possible outcomes of an event. So again, if you go back to the example of flipping a coin, the possible outcomes there are heads or tails. So the notation for sample space, it's written in something called set notation. And the way that's written is we would say S, or the sample space, is equal to, we use these squiggly brackets, and then we just list the outcomes. So outcome 1, outcome 2, etc. I think this will make more sense when we look at an example. Okay, so example 1. E is the event that a regular die is rolled and gives you an even number. Okay, so that's the event that's being described. We wanted to determine the sample space of rolling a regular die. So if you think about that, what are the possible outcomes when you roll a dice? Well, it's number 1, number 2, 3, 4, 5, and 6. So the way we show that mathematically with that sample space notation is I just write S equals, and now I just list all the possible events there. So that's rolling a 1 through a 6, and I close it up with a squiggly line. Okay, so in part B, we're asked to find P of E. So what that means is, what is the probability of rolling an even number? So P there is probability. So the probability of an even number, if I go look at my sample space, I have 2, 4, and 6 are the even numbers, and the total possible outcomes there is 6. So the probability of rolling an even number is 3 out of 6, and that simplifies, of course, to 1/2, or 50%. All those are equivalent probability statements. Okay, example 2. If A is the event that the spinner below lands on 2, what is P of A? Alright, so A is the event of the spinner below landing on 2. First of all, what are the total possible outcomes here? Well, there's 4 possible outcomes. We could land on 1, 2, 3, or 4. The probability of landing on a 2, because that's equally likely in that spinner, is really 1 out of 4. 1 out of 4, of course, simplifies to 0.25. Okay, there are some practice problems below that ask you to write down about the sample space and determine the probability.